example related to the equipotential surface, voltage, electric field or electric current. So electrons are accelerated and then they are directed between the two parallel plates as a part of a CRO cathode ray tube, CRT cathode ray tube as shown. So this is a beam of electron. It is passing through two metal plates, parallel plates, which are 10 centimeter apart. And the length of the plate is 5 centimeter. For the region between the plates, find the electric field strength. How to find the strength of electric field or electric field strength? So we have the formula. When parallel plates are there, as we know, electric field strength is voltage divided by distance between the plate. So voltage is how much? It's 100 volts, and the distance plate between the plate is 10 centimeter. So what we'll do, we'll convert into meter by dividing with 100. So it will be 100 divided by 0.1. So you will get 1000 or 1 kilo. The unit of voltage is volts and the unit of distance is meter. So it is volts per meter. You can write capital V slash M. This is one of the unit of electric field. There is also another unit for electric field. As we know, electric field E is equals to F divided by Q. So you can also mention Newton per Coulomb. Both are the unit. Newton per Coulomb or volts per meter are the units for strength of electric field or electric field strength. That's the first part. For the second part, the force on the electron. So how to find the force on electron? We have the formula E is equals to F over Q. So we have the electric field and we know the charge of electron. So we can find the force which this electron will experience in this electric field. As we know, between the parallel plates, the electric field is constant. So as the force, so we can find this force. Force is equals to E multiplied by Q. Q is the charge of one electron, that's 1.6 exponent minus 19 Coulomb. And the strength of electric field, which is 1000, we already calculated in the previous part. So we multiply and we'll get 1.6 exponent minus 16 newtons. Then, given that the velocity of a beam is 1 exponent 7. So at this point, this beam velocity was 1 exponent 7. Now what happened? As it enter the electric field, the moment it will enter the electric field, the higher potential plate is called a positive plate and lower potential plate is called a negative plate. So what happened? This beam of electron, as the higher potential plate is a positive and lower potential plate is a negative. So positive plate will attract the electron, so electron will deflect or it will follow a curved path. So as this electron will follow a curved path, now its velocity will have two components. What are the two components of the velocity? One is a horizontal component of the velocity. One is a horizontal component of the velocity and another one is a vertical component of velocity. The horizontal component of the velocity is not affected by the electric field. The component of the velocity which is affected is a vertical component. That's why you can see it is moving either or curved down or upward or downward. So in the beginning, when it entered the field, you can see here, it entered the field horizontally. But the moment when it entered the field, there are two components. Every point there are two components. One is a horizontal, another one is vertical. Horizontal component does not change. The vertical component is increasing because it is accelerating as it moves towards the plate. This is a theory of this CRT cathode ray tube. Now in the question, given that the velocity of a beam is 1 exponent. So given that the velocity of the beam is 1 exponent 7 meter per second, find the time spent between the plates. Like how much time it will take to cover this 5 centimeter. So 1 exponent 7 is a horizontal velocity and horizontal velocity remains same throughout. It does not change. But what happened to vertical velocity? The moment when it entered the field, that moment the vertical velocity is 0, but then the vertical velocity start to increase because it is experiencing the force. The force caused its acceleration. That is why the velocity will increase. So first we need a time it spent between the plate. So time spent between the plate as a horizontal component velocity does not change, and the distance, the horizontal distance is 5 centimeters. So we'll convert into meter. So it is 0.05 meters. And we have this simple formula: speed is equals to distance over time. So time is equals to distance divided by speed. So what was the distance? The horizontal distance is 5 centimeter, which is 0.05, divided by speed at which it travel, or horizontal speed, because speed will have two components. The moment it entered the electric field, the speed will have two components. Before that, it was moving horizontally, so then it was having only one component. Then what happened? The speed was given a horizontal component, which is 1 exponent 7. So when we divide, so what we'll get 5 exponent minus 9, which means 5 nanoseconds. In the second part, the acceleration of electron, because it has an acceleration in a vertical plane. So how to find acceleration? We have the formula F is equals to ma. So force divided by mass is equals to acceleration. Force we already calculated in the part A2. We calculated the force on the electron. So we have this force, and mass of electron you don't have to memorize. At the end of constants, the values will be there. So you can identify, you can use that. But in the question it's given, the mass of electron is 9.11 exponent minus 31. So force divided by mass, you will get the acceleration, which is 1.7 exponent 14 meter per second square. The vertical displacement of electron as it leaves the plate. So we need the vertical displacement. What does it mean? Like example, as you know, as this electron enter the electric field, it deviates from the original path. So it will have two components. We need what is the vertical distance displacement. Basically, it is having from the starting point. This is a horizontal displacement and we need a vertical one. So we need this x. So how to find it? Whenever there's in a motion, there's acceleration. So we always use equation of the motion. So we'll use S is equals to ut plus half at square. We know the time it is taking to travel between the plate that we already calculated. It was 5 nanosecond. Initially, the vertical velocity here 0. When it entered, all the velocity was horizontal and there is no vertical component of the velocity. So vertical component was 0. So we substitute in place of u, we substitute 0. So what we are left with, S is equals to 1 by 2 at square. So we have acceleration. That's from the previous part. We use F is equals to ma to get that acceleration. We have the time it took to travel between the plate, which is 5 nanoseconds. So we just substitute them and we will get the final answer, which is about 2.2 millimeter. Is it clear? And what is our assumption here? Basically, it accelerated due to electric field, and we assume that weight or the force of the gravity is negligible, which does not contribute to its acceleration or deceleration. Is it clear, this example?
Yes, it's clear.
Electric potential for a point charge, parallel plate capacitors, and a hollow sphere. So as we have the formula, you can see we have the formula electric field is voltage divided by distance, or we can say the electric potential is equals to electric field multiplied by distance. We know for a point charge, what is a point charge? When all of the charge is concentrated at one point, we call that as a point charge. Like example, the size or size of the particle is negligible. So we can say that's a point charge. So electron is a point charge. And the electric field for a point charge, that is given by K Q over R square. That's the formula for electric field. Multiplied by distance. So distance is also, like example, if I have electron and I want to find a potential at a point, at point 1, which is at a distance d or r away from this electron. So if I use a formula for electric field strength, I'll say electric field strength or electric field intensity is equals to K. Q is the charge of that particle divided by R square. But if I need voltage, so it's electric field multiplied by distance from the charge. The distance from the charge is also R, so R square will cancel with R. So you can see the potential is equals to KQ over R. So what it shows that the relation between voltage, the electric potential and the distance, it is inversely proportional. But the relation between electric field strength and distance, it follow inverse square. Inverse square means if a distance is double, if I double the distance, the electric field intensity will decrease by 4. If I triple the distance, electric field intensity will decrease by or divided by square of that number, so it will decrease by 9. But for electric potential, you can see if R is or distance is double, what will happen to voltage? Voltage will be divided by 2. It shows an inverse relation. So the two graphs, one is for electric potential, another one is electric field strength. Electric field strength shows a greater variation as compared to electric potential. Is it clear? The two graphs, it just shows a relation that one is inversely proportional, another one is inverse square relation. Inverse square relation shows that if a distance is doubled, the change in voltage, a change in electric potential will be more as compared to. So if I say you have a charge and at a certain point, say at a distance of 2 meters, the strength of the electric field strength was 100 Newton per Coulomb or volts per meter. And the voltage example was also 100 example. But if I double the distance, if we move to another point which is 4 meters away from the charge, so what happened? Electric field strength vary with inverse square. Means if distance is double, this will decrease by 4. So electric field strength will decrease by 4, means it will become 24. And voltage will decrease because for voltage it is inverse law, and for electric potential it is inverse square relation. So if distance was 2, it changes to 4. So if it is multiplied by 2 distance, electric field intensity or strength will divide it by 4. That's why originally it was 100. Now it become 25 Newton per Coulomb. But what about voltage? It follow inverse square because the distance is doubled. So potential will decrease by 2. That's why this voltage will be 50. Is it clear? Any doubt in this? Next, for a parallel plates or a capacitor, if we sketch a graph for electric field, and we sketch a graph with respect to distance. The previous also was distance and voltage or distance and electric field. This parallel plates, if two parallel plates are there, or you can also say capacitor. So it has two plates, one is positively charged and the other one is negative charge. Now electric field strength E is equals to F divided by Q. And say this was at a distance, the distance between the two plates is D. So what happened if you have a charge near the, say electron was near the positive plate, another case electron was exactly at the center, and another case electron is nearby the negative plate. So what happened? The resultant force, the force from the positive plate will change, the force from the negative plate will also change, but the force, the resultant force will be same. When it is closer to the positive plate, so attraction is more and repulsion is less. So example, if attraction was 70 and the repulsion was 30, so what is the resultant force? The resultant force will be 100 Newton. Same way, if it is exactly at the center, so attraction and repulsion will be same. Example, the attraction is 50, the repulsion is also 50, but the result will be 100. And when it is near the negative plate, so attraction is weaker, but the repulsion is more, and the resultant force is in the same direction and with the same magnitude. Maybe this was 20 and 80, but what happened to resultant force? All the cases, the resultant force will be same. So if the resultant force is not changing, resultant force is constant, charge of the particle is constant, so the electric field strength will also be constant. So when you sketch a graph for electric field versus distance, any point you take, you will find that the distance is, with respect to distance, the electric field does not change at all. This is when you sketch a graph for electric field versus distance. For parallel plate, the strength of electric field or electric field strength remain unchanged or it will remain constant. But what happened to voltage or electric potential? Actually, the definition of a voltage is it is work done on a positive charge. So work done, this is a definition of electric potential. So the standard definition is what? The potential or electric potential or voltage at a point in electric field is defined as work done in bringing a test unit positive charge from infinity to that point. Like how much work is done for a positive charge, that's called electric potential. So according to definition, it's only standard for positive charge. So what happens if you have two parallel plates? So voltage is work done per unit charge, and we know work done is force into distance. So voltage, we can say force into distance divided by charge. And this force is not the resultant force. This force is a force experienced by a positive charge, because that's a standard definition for electric potential, that is only the work done on a positive charge. So if we have two parallel plates and I have a test positive charge, and the distance between the two plates is D, so if I try to move this charge closer to the positive plate, means I have to do a greater work done, because I have to apply more force as we are moving closer to the positive terminal or positive plate, like charges repel each other. So as the repulsion increase, the force from the positive plate will also increase. So the work done or work which we have to do will also increase. That's why when it is closer to the plate, we have to do a maximum work done or maximum voltage is there. And when we move away, we don't have to apply too much force because it's away from the positive plate. So work done will decrease. So when you sketch a graph for electric potential versus voltage, so what graph you will have? You will have a graph, a linear graph, a straight line graph or a linear graph which shows a relation between voltage and distance. So at the minimum distance, maximum voltage. Why? Because greater amount of force is needed or required to move closer to the positive plate. That is why the positive plate is known as the higher volt plate. Like example, if it is written 30 volts on one plate and 15 volts on another plate. So the one which is having a higher voltage is always a positive plate and the smaller voltage is refers to negative plate. It can be zero as well. Zero, the smaller one is a negative plate and the higher voltage one is a positive plate. Why? Because we have to do more work done if we move the positive, if we move a test or a unit positive charge closer to a positive plate. That's why higher potential is always, the plate is always refers to positive plate. Is this clear, this graph about the voltage and movement or distance? Then for a hollow charge sphere, as we know, for a hollow charge sphere, inside the sphere, there is no electric field. And outside it act like a similar or same way as it used to show a same relation like a test charge, a unit test or a point charge. So when we sketch a graph, why the voltage is higher? Because it's having more charges. So if more charges are there at a certain point near the charges, there is a greater amount of force. That's why the voltage is higher, or voltage will start with a higher value. Here you see a constant voltage within this charge sphere or the hollow sphere. Electric field is zero. That's why the electric field is starting at a certain, like what is if I say this is a radius, this r is a radius of this sphere. So what happened? The electric field, there is no electric field inside. So as there is no electric field inside, that's why the electric field is zero till the radius point. Once we reach the surface, then it will have a maximum electric field. As we move away from it, the electric field will decrease, and it also follow the inverse square relation, because that's also given by E is equals to kq over r square. What about the voltage or the potential? Within the sphere, the voltage is constant, and then the voltage start to decrease. Means, what is the voltage? Voltage is force work done per unit charge. So force into distance divided by charge. So if we have a hollow sphere, because the definition of electric field, it is work done on a unit charge. So where if we move a charge anywhere till the surface, there is a constant work done, same work done or same energy, any point. Because if I apply a force and move the object to certain distance, it will not make any difference because there is no electric field. So that is, can say the electric field strength is zero inside. That's why it does not experience force due to the positive charge. So the force which we apply, the distance which we move and divided by charge will get the same voltage. Once we are come, it will be outside, then it will also follow the inverse square law. So V is equals to, so voltage is equals to K, in not inverse square, V is equals to R. This is the same formula which we used previously for a point charge. So we use the same formula for a hollow sphere, but within the sphere, the voltage is constant. Constant voltage means same work done per unit charge is there. But when you move away from the sphere, the work done per unit charge decreases. Because I have to do the same work done to reach the surface. But once I reach the surface, now the work done per unit charge changes or decreases because the electric field strength is also decreasing. Now this is an important topic, capacitor. What is a capacitor? Capacitor, the purpose of the capacitor is it is used to store the electrical energy. We don't say it is used to store electrical charges, because practically if you say it store electrical charge, then it is wrong. Why it is wrong? Like example, you have two plates. Two metal plates, and you connect this with a supply. So when you connect this with a supply, so the positive terminal of the battery, because it's a metal plate, or what is the structure of the metal? Metal consists of a lattice of a positive ion and the delocalized electrons. Example, this is just an example. If there were 3 electrons and 3 positive ions, the other one also initially there were 3 electrons and 3 positive ions. So as the like charges repel and unlike charges attract, so electron experience the attraction. So as these electrons experience the attraction, they will come out from the metal. As these electrons move out from the metal, so what we will observe, that electrons are removed. As these electrons are removed, the net charge will be positive. So example, if 2 electrons are removed from this, so the net charge will be +2. And the negative terminal of the battery supply electrons, so electron will move from negative terminal of the battery towards the plate. So this will have majority electrons. So example, 2 extra electrons are there. So what is the net charge? The net charge is -2. But what is the resultant charge on the plate? The resultant charge is 0, because +2 and -2, so that makes 0. That's why we don't say that capacitor store electrical charges. We say the capacitor store electrical energy. Because if we say electrical charge, but there is no net charge, if it store electrical charge, then the number of the charges or net charge should increase. But the net charge is 0, so it shows at it is stored electrical energy. And this process in which we connect a battery and we allow the movement of the charges to take place, this is called a charging process. And this charging process will continue for some time and then it will stop. Why this charging process will stop after certain time? Because what happened? Like charges repel each other. So as there are enough electrons present in this plate, these electrons will not allow the electrons from the battery to come and stop on this plate. That's why the movement of electrons stops. So as the movement of electrons stops, and these electrons were helping the other electron to go out as well. How they were helping the other electron to go out? Like example, if 1 electron enter here, so now we'll have 4 electron, and here we have 3 electrons. 3 electron and 3 positive charges. But what happened? This extra electron will repel the electron from other plate. So it will push this electron out from the plate. That's why the net charge on the other plate will be positive. So this is how a charging of a capacitor is done. And how much charge is stored for every volts, that is called capacitance of a capacitor. So like example, a capacitor can store 3 coulombs per volt. Means if I connect it, because the charge stored by the capacitor depending on the supply we use and the type of material used to make this capacitor. So if I supply example a 10 volts supply is there, and using this I was able to store 10 coulomb charges or 100 coulomb of the charges. So what is the capacitance? Capacitance means how much or how many charges are stored for by applying 1 coulomb or each coulomb. So that's capacitance will be 100 divided by 10, charge divided by voltage. Charge was 100 charges were stored for 10 volts. So it will give you 10 coulombs per volt. Means it can store 10 coulomb for every volt. So but the capacitance is having a constant value for, it depends on the size, the material for which the capacitor is made up of. So it vary from material to material, the value of the capacitance. Higher value of a capacitance shows that the capacitor can store greater amount of charge. Smaller value of capacitance shows that the capacitor can store smaller value of the charge or smaller amount of charge. So if we have these parallel plate capacitors, identical capacitors are there. If I connect this with a 2 volt supply, and I connect the other one with 5 volt supply. So 5 volt means more work done per unit charge. Greater work done per unit charge means more charges can be pushed on this capacitor plate. So it will store greater amount of charge. So like example, this can store using a 2 volts, you can store 10 coulomb of a charge. Using a 5 volt, you are able to store 100 coulomb of the charge. So what is the capacitance? How much charge can be stored by apply? If we want to apply 1 volts, so it will be 10 divided by 2, which is equals to 5 coulomb per volt. But this one, the other one, 100 divided by 5, so it is equals to 20 coulombs per volt. So this capacitor can store greater amount of charge for every 1 volt supplied. So higher value of a capacitor means more charges can be stored on the capacitor. The capacitor can only work with DC. Capacitor cannot work with AC. Why the capacitor cannot work with AC? As we know, alternating supplies or AC supplies, the direction of the conventional current or current is not constant. It continuously changes. Like example, first, if the left hand side is positive, right hand side negative, the conventional current or the charges will move from positive to negative. So they stop. This will have, this is the direction of the conventional current, but in reality what happened? In reality, you don't have any conventional current. Actually, the electrons are moving out, coming out from the plate, so make it positive, and moving towards the plate, making it negative. An equal number of the charges. Why? Because the charges push each other, so that's why they are equal in number. Why AC cannot works with AC? Reason for that, alternating current continuously changes its direction. So if first this is positive, the other one was negative, so current moved and it moved towards this side. But what happened if the capacitor, because it's an AC supply, next moment left hand side positive, right hand side negative, so the electron which were stored in the capacitor will return back to the battery. So with AC, the capacitor cannot block AC, or capacitor cannot store charge by using AC. So it only works with DC. And if we connect a high voltage supply, capacitor is storing greater amount of charge. So if we sketch a graph for voltage and charge is on y-axis and voltage on x-axis. So there will be a straight line. So there will be a straight line which shows that increasing a voltage across the capacitor will increase the charge on the plate. And when we find the slope or the gradient of this, what we get? We get a capacitance. What is the unit of capacitance? Capacitance is charge per volt. So unit of the charge is coulomb and unit of the voltage is volt, so it's coulomb per volt. But there's also another unit, coulomb per volt, is also known as farad, and it is denoted by F. But normally it's like microfarad, picofarad. Very small values are there for a capacitance. Is it clear, the concept of capacitor, charging of a capacitor? This is a charging of a capacitor, then capacitor can discharge as well. So in this example, like if we connect, and the charging and the discharging directions are always opposite. Like example, we connect to position A. So when we connect to position A, what happens? Positive terminal will attract the electron, but we always, in a circuit, we always draw the conventional current. So we show conventional current is from positive toward this plate. So this plate will be positively charged. And conventional current towards the negative. So this plate will be negatively charged. But in reality, electrons move and the direction of movement of electron is opposite. So once the capacitor is charged, this is a two-way switch. So we change the position of the switch. The moment we change the position of the switch, so what happened? As the capacitor, this part was positively charged. And this is negative charge, so it will supply the current through the circuit. What is the advantage of using a capacitor as compared to a battery? Like, why not directly a battery is connected for this operation? Actually, capacitor charging and discharging is exponential, but battery charging and discharging is not exponential. Like example, what happened? If you have a battery, so a battery is continuously supplying you a constant current, a fixed value of the current. But what happened in capacitor? When you're using a capacitor, it provides a burst of the charges. So maximum in the beginning and it will start to decrease. What is the advantage of this? The total number of the charges here is same as total number of charges here. But the difference is that it provides a burst. So it will produce a greater magnetic field. And this effect can be used, like example, for a fan, because fan is stationary. So it required a greater amount of force to move initially. That is why when you switch on the fan, first a capacitor charge and it give a burst of the charge to the fan. So suddenly it will start to move. With a 2 ampere, maybe this is supplying, the current will be higher. Why this is a higher current? Because maybe it is providing a 7 ampere current.